Hey gang, welcome to week 3 of Code Club Year 2. This week, we're going to learn a little bit about game physics while we make our hero move around. Open up another browser window and log on to Cloud9 so that you can follow along. Have fun and let's start coding. If you remember, we left off last week with platforms and a hero, but the hero couldn't move on the screen yet. So this week we're going to add the ability for our hero to move left and right on the screen. He won't be able to jump yet, but he'll be able to move left and right. In order to understand how to make our hero move on the screen, we need to understand a little bit about game physics. In real life, physics is the scientific study of how physical things interact. So what happens if you drop a ball? What happens if you throw two balls at each other and they collide? What happens if you throw a ball at a wall and those things collide? In programming, a physics engine is used to model the physical world inside the computer. So you can do things like, what happens if my hero falls down? Or if he jumps on a coin? What's the gravity like in my world? Because we're faking physics with a model, we can have the gravity be like Earth or like the moon or like anything else that we want. A physics engine is what lets you do all of these physical interactions inside your game. For our programming, Phaser.io adds a game physics engine to JavaScript. And the way it works is every sprite can have its physics turned on or off. If the physics are turned on, then the sprites can interact with each other. So for example, if we have a platform and we have a hero character, in order for a hero character to be able to walk on top of a platform, it needs to have its physics engine turned on, and the platform needs to have its physics engine turned on. And I'll switch back to code now, and the first thing we're going to do this week is actually turn physics engine on for our hero character. And the way we do this is in our hero constructor. Remember, the constructor is called every time you create a new hero. In the hero constructor, we'll add a new line of code that says game physics enable. And it's doing exactly what it sounds like. It's enabling game physics for this hero. The next thing we need to do is to tell our hero what it does when it's supposed to move. To do this, we're going to add a new function called move to our hero. Now, it's very important that this new hero prototype move function goes after this line of code that tells it to create a hero. And the reason is, if we don't have this line of code yet, this line of code doesn't know what a hero prototype is. So it's just very important that when you add new functions to an object that you're creating, the functions go after the hero prototype creating part. There are two lines of code in the move function. The first one says the speed of the hero is 200. The second one says move the x velocity of the hero in the direction that's specified in the parameter that's passed in at the speed that we tell it. So this is what's saying move the hero along the x-axis that's back and forth in the direction that we want at the speed we want. One thing you'll notice here is that I'm using this const keyword when we're setting the speed. And const stands for constant in JavaScript. And it means that when you set the value for this, for speed, it's going to be the same throughout your entire program. Nothing else in your program can change the value. So when we set speed to 200, it's going to stay 200 the entire time. And speed being in all capital letters, because it's a constant, is not something that JavaScript requires, but it's a very good programming practice that a lot of people use to have constants be in all capital letters. If you were to reload the preview window right now, the hero still wouldn't move around, and that's because the move function doesn't actually know what direction to go because we're not interacting with the keyboard yet. We need to tell Phaser that we want to use the keyboard and what we want certain keys on the keyboard to do. So the first thing we need to do is add some code right here before preload that tells Phaser that we want to use the keyboard and that we want to use the left and right keys. So it's an init state that we're adding to our game, and it's saying we want to use the keyboard and we want to use the left keys and the right key specifically. There's also this other line of code here which we don't need to worry about. It just fixes a graphical bug in Phaser that we're not going to worry about. We just need to fix the bug. One thing you might notice now if you're looking at your code is that we have an init function, a preload function, and a create function. And it's weird. Why can't you just have one thing that does all the game setup for you? And it's just the way Phaser works. What it wants you to do is in the init function, that's where you set up variables and things like that that you need before the game starts, before preloading starts. It goes from init to preload, and preload is where it wants you to load all the assets that you need. So that's where we're loading our data files and our images that we need for the game. And then create is called after preload ends, and that's typically used at where you do startup tasks that need the assets that you loaded in preload. So it's just a separation that Phaser kind of enforces on us to make sure that things happen in a proper order, and we think about the proper order as we're doing it. If you remember our talk about game states, I said there are two states that Phaser calls over and over again, update and render, and it calls those really fast, 60 frames per second. To get Phaser to constantly check for keyboard input, we're going to add an update state, and that's where the keyboard handling code is going to go. So that goes right after the playstate.create function. We're going to add playstate.update. In the update function, right now we just have this.handle input, and handle input is going to be a new function that we add at the end of the file. And this is because the update function is going to do a lot of different things. We don't want to have a bunch of different code in here. We'll just have a bunch of different function calls instead to make the update function cleaner. So at the end of our file, we'll add a handle input function. In the handle input function, we have what's called an if tests. If tests look at what's happening in your program and then run different parts of the code based on what it sees. In handle input, we're saying if the left key is down, then move the hero direction -1. Otherwise, if the right key is down, move the hero in direction 1. Otherwise, if neither the left key or the right key is down, then move the hero in direction 0, which means don't move at all. If tests are a huge part of computer programming, and using them in combination with looping, which we talked about a little bit last week, is what makes programming a very powerful tool, because if tests and loops make it so that your program can make decisions based on your data. Here, it's on the data of what keys are pressed down. It's making the decision of what way to move our hero. If we save our code and go back to the preview now, the hero moves around. And it's not very fancy. Like I said, he can't jump, but he moves around. One thing you'll notice, he doesn't interact with this platform yet because we haven't turned on physics for platforms. The other thing you'll notice is if you go all the way to the left or all the way to the right, the hero goes off the screen. And we don't want that to happen either. To fix the problem of our hero going off the screen, we're going to add some code to our hero constructor. And what this says is the hero is going to collide with the boundary of the world. That means the two left sides of the world and the top and the bottom of the world. The hero's not going to be able to go past them. Sometimes when things collide, we'll want other things to happen. For example, what if we drop the ball? We might want it to bounce on the floor. Or if you remember Angry Birds, you catapulted a bird at some TNT. When the bird and the TNT collided, you would want the TNT to explode. For this, we're just saying stop. That's the only interaction we want, is when the hero hits the world boundaries, we want it to stop. The code is very simple. It's just setting this predefined variable that's part of a hero to be true, and it's part of a hero because it's part of a sprite. It inherited that from the sprite object. This type of variable is called a Boolean, and what that means is that it can only be true or false. If you tried to set this to something else, like if you tried to set it to your name or something, that would make this line of code fail. If we go back and look at our preview now after we save, now our hero can still move around. He still moves through platforms, but he's not going through the ends of our game world anymore. Next week, we're going to add the code that allows our hero to actually jump on top of the platforms instead of just running right through them like it does right now. Alright, that's it for this week of Code Club. I hope you enjoyed it. We'll see you next week.